School. I'm your science teacher. We are learning chapter 8, motion. Yesterday we have introduced distance time graph. Today we are going to again see distance time graph, and we are going to see two more topics called velocity time graph and equations of motion. Right? I'll introduce you, then you can got to know what exactly the difference between two graphs. They may look same at one instance, but their interpretation is different. Let me show you. Okay. Now yesterday we learned three graphs. Okay. The first graph is distance time graph. See this one. Okay. In this graph, if you see distance means we represent it as s, and time we represent as t. So this is how you have to show whenever it is a distance time graph. You have to show like this. Now let me draw three of them, so that will help you to understand what it means. So here also this is distance and this is time. So there are three graphs. I'm going to show you three of them all at once, so you can got to know easily what it means. Okay, now the first graph I told you is like this, straight line. The second graph is a curved line, and the third one is a parallel line parallel to the x-axis, basically the time graph. So what does this three of them represents? This is uniform motion. Yes. Why it is uniform motion? Again I told you, uniform motion, if you find out the distance versus time. For example, I said this is 1 hour, let's say this is 2 kilometer, then it is 2 hour 4 kilometer, then it is 3 hour 6 kilometer. So if you see the change in the distance, equal distance in equal interval of time, that is the definition of uniform motion. If an object travel equal distance in equal interval of time, then we call it as a uniform motion. This is a non-uniform motion. The second graph says you is a non-uniform motion. Okay. Now here, if you try to find out, the distance and time are not matching. If it is 1 hour, this is might be 0.5 kilometer. If it is 2 hours, this is, let's say 2 kilometer or 1 kilometer. Right, then it is 3 hours, then it is like 3 kilometer. So the gap is not same. So if an object does not travel equal distance in equal interval of time, we will call it as a non-uniform motion. Now if you see here, the time is increasing, but the object, let's say it is at 4 kilometer, the object which is at 4 kilometer, it is there only 1 hour, 2 hour, 3 hour, 4 hour, means time is increasing, but the object is still there. What does that represent? The object is not moving, so it is stationary. Yes. Okay. So three equations of motion here. Right. Let me show you again in our textbook. So our textbook shows the same thing. Right. See, distance versus time graph. The first one is a uniform motion. The second graph is a non-uniform motion, and the third one, right, which they have not shown you, but I showed you, that is a stationary. Now we are going to see the velocity time versus time graph. Now if you see here, this is a parallel line, right? Now see, let me show you here. In the same page only I am going to show you, that will help you to introduce a little more better. I will draw with some different pen, so that will help you to understand. Let us say this is a velocity versus time graph. Now when you draw a velocity versus time graph, okay, and this is parallel line. Now this is velocity, so we represented v and t. Okay, now this is a parallel line. Now tell me, what do you think? Is this a stationary motion? Think a little, think. Is this a stationary motion? I am talking about a velocity versus time graph, and a line is parallel to x-axis. Now in this case, when a line is parallel to x-axis, just think a little. What does it interpret? What does it interpret? That the time is increasing, but the speed is not increasing. Let's say this speed is 30 km per hour. So 1 hour the speed is 30, 2 hours the speed is 30, 3 hours the speed is 30. What does this represent? The speed is not increasing or decreasing. The time is increasing, but the speed is not increasing. So is it stationary? No, this is not stationary. Why it is not stationary? Because it is moving. Velocity. What do you mean by velocity? Velocity means it is going, right? It is having velocity, means it is not stationary. It is not there. So here this is not stationary. This is, come on, this is uniform motion. Yes. So understand the difference between these two. So here when the graph in distance versus is parallel to x-axis, this is stationary, but here when you see the same graph in velocity versus time graph, it is uniform motion. Okay. Now let me show you the another one. What does this mean here? Now I am going to draw the velocity versus time graph, and it is a straight line, the way it has represented. Okay, again this is the velocity versus time graph. Okay, now, so what do you think now here? Here if you see, the time is increasing, okay, and the velocity is also increasing. Let's say this is 10, in 2 hours it is 20, in 3 hours it is 30. So if you see here properly, here also the time is increasing and the velocity is also increasing, but the velocity is increasing uniformly, right? So definitely that something is called uniform motion, but here the velocity is increasing. So what do you call? We do not call it just simply as a uniform motion. We said uniform accelerated motion. Yes, what I told you, what is acceleration? The speed is increasing or decreasing, right? So this is just not uniform motion, this is uniform accelerated. Uniform motion is, we just saw the parallel line parallel to x-axis. So don't get confused between two graphs. That's why I'm showing on one page. I hope you can note it down in your book for your reference, right? Whatever question answers I'll give, that you have to write down for sure. But this, for your reference, you can write down on one page. Few things, now you put a habit of writing your own notes. That will help you to refer things, because that is what going to take you ahead, and that practice you have to start from 9th standard. Okay, now, then what is non-uniform motion? Okay, so let me show you that also. So now here, let's say this is our graph, and the graph is moving like this, like zigzag, right? Again this is velocity versus time graph. So what does this represent? This is non-uniform motion, right? What is this? This is non-uniform. Why it is called non-uniform? Because if you see, the speed is increasing, decreasing, increasing, means it is increasing or decreasing, but it is not increasing, decreasing in equal amount of time. So that's why we call it as a non-uniform motion, right? So I hope you are getting what I'm trying to say, difference between an uniform motion, non-uniform motion, stationary, right? Here there is no graph of stationary, because if you have a graph of stationary, the line does not even exist, because velocity will become 0. If it is stationary, the velocity is 0. So x-axis itself is a graph, but that doesn't show a graph. So in velocity versus time graph, we do not have stationary graph. Uniform accelerated motion, non-uniform motion, and there is one more graph I'm going to show you, right, which we call it as a, I have to erase this, let me erase and show you. One more graph I'm going to show you, let you only tell me what does this mean, okay. So here, let me put it in this way, and the graph starts from up and it is going down. Now, what kind of graph is that? Let's say the speed is increasing, this is the speed, let's say it is 50 km/h, right? So then In 1 hour it is decreased to 40 kilometer per hour. Then in 2 hours it is 30 kilometer per hour, 20 kilometer per hour, right? It is decreasing basically. So when the speed is decreasing, what motion do you call? Retarded motion, right? Remember, I told you acceleration can be represented in two forms. One is accelerated and another is retarded. So this is retarded motion. I hope you are getting. So there are 4 graphs. Let me show you in our textbook. So this is first one. Can you see this one? They have already written velocity time graph for uniform motion of a car. Second, see this one. Now this one we already, this one, the one which is on, that is uniform acceleration. Can you see? Uniform acceleration. The upper one which I showed you just now is the retarded motion, A, and the B is non-uniform accelerated motion. Okay. So these are 4 graphs we learned in a velocity versus time graph. These are 4 graphs which are learned in a velocity versus time graph. I hope you are getting, right? Please put your effort to read textbook every day. That will only going to help you. So we learn velocity versus time graph, we learn distance versus time graph. Now the next topic is equations of motion by a graphical method. Now the derivation I am going to show you tomorrow, but what are those equations of motion? Let me show you. There are 3 equations of motions. Equations of motion, again I am telling you, what do you call? Equations of motion. So there are 3 equations of motion. V is equal to u plus at, S is equal to ut plus half at square, and v square minus u square is equal to 2as. These are 3 equations of motion. Now I already told you what is V. V is final velocity. Now understand, people only here only people get confused. Then how you are going to do word problems? So I always tell everyone, you know each and every quantity and you know each and every unit of that quantity, right? So this is what is the unit. Also I will write down. U is initial velocity, S is distance, T is time, right? What is left? A is acceleration. Okay, and this is meter per second, this is meter per second, this is meter, this is second, and this is meter per second square. So understand, these are all the SI units and this is the quantity. So this is also, you keep it as a note. Tomorrow we are going to discuss how to derive this equation from a graphical method. See, our textbook tells you how to derive the equations of motion by graphical method. Okay. So I hope you are getting. We learn 3 things. Put all your effort. I think 1 or 2 lecture we are going to finish this, and I am going to give you the notes of the same. Okay. Till then, bye. Take care. See you tomorrow.